Hi, I'm Leslie Black. I'm a Microsoft Application Specialist working for Analysis Cloud, the Irish cloud company. I have experience working with governmental organisations in Europe and the UK, building reporting, analysis and performance management systems using Microsoft tools. I've recently finished working with the European Commission, building a large-scale 100% cloud-based COVID reporting application built on Azure, Power Platform and Office 365. It was on that project that I became familiar with Office scripts. The key messages for this demo are: think of Excel Online as a calculation engine, available to assist your built online apps. 2. Complex automation tasks can be written using Office scripts, but Power Automate can reduce that complexity by handling the logic instead. It is your choice. 3. Excel Online has the power and capability to be used as a front-end user interface for your web-based applications. And 4. Because Excel Office Scripts is integrated with Power Automate, it opens up a whole world of Azure services and data sources available for your solutions. Let's have a look at the user interface. So here we can see in the worksheet called TicTacToe, the options available to us are you play first by placing a marker in the grid, Excel plays first, or you can clear the board and start a new game. When you enter a marker in the grid, Excel responds by putting an X marker into the grid into a different position. You cannot enter an X marker as that is reserved for Excel. You can use any marker that is not an X or a capital X, and the markers can be different from each other. When the user wins, i.e. Excel loses, an animation starts. The time taken for Excel to make its turn is displayed in cell N6. The associated Power Automate flow contains only 3 connectors: the trigger, SharePoint when a file is created or modified in a folder, and 2 action steps, a condition and an Excel run script. Because Excel currently has only 1 trigger connector in Power Automate, which is not applicable to this scenario, it leaves only the SharePoint file trigger to us as the application's event trigger. This means any change to the workbook file will trigger the Office script. Even modifying an attribute of the file in SharePoint will trigger the Office script. That is, it is not only changes to the workbook contents that triggers the script. When a marker or any other change occurs in the worksheet, the script needs to ascertain where that change occurred and what type of change occurred. This is done by testing the values within the grid and cells M6 and P8. The time for Power Automate to respond to the entering of a marker is in addition to the time it takes for the script to run. The scripts can take from around 15 seconds up to 70 seconds. The Power Automate trigger ranges from 10 seconds up to 110 seconds to run. So Excel can take up to 3 minutes to reply with its marker. Let's now have a look at the application and get Excel to take a turn. When the script is triggered by the flow, it runs very quickly and the animation does not display. So in order to show you the animation, I have to manually run this script, which is what I did here. Also, one thing I want to point out is that you noticed an error message that appeared showing that the page was not responding. I clicked wait and then it continued to run and the scripts ran. That error is extremely rare, but it's interesting that I managed to capture it when recording this demo, and it's something that happens perhaps during the evening hours or early hours of a morning, perhaps when things are less busy. One thing I do need to also point out is that the time that it takes to run the script as well as the trigger can vary quite considerably based on the time of day, and also we need to consider that during the day might be, for example, in the US, but at the same time it will be evening in Europe. So these different loads on the Azure and Office servers does have an impact on the duration and responsiveness of your Power Automate and your scripts. The script is 3002 lines long, 1977 lines of which are for the animation alone. With the Excel macro recorder, building solutions is now extremely rapid. The animation element of this app was built in less than half a working day. That is, 1977 lines of TypeScript code was written in less than 4 hours. In the single script file, there is a total of 20 functions, including the main function. The main function is 369 lines long, including the lines of code that control the animation. The total number of lines of code is 960. This is a surprisingly large number considering all you're trying to do with this game is to put an X in an empty cell in the grid. But that is not the full story. Here is a full list of the functions used in the script. The functions marked with an asterisk are those used for the animation only. The getRangeCount function counts the total number of markers entered in the grid. The findLocation function iterates through the grid, finding a cell that is not listed in Table 1. Table 1 is used to record the locations of the entered markers and the order in which they were added to the grid. It is hidden from user view. The add marker location to Table 1 function adds the recently added marker location to the next available row in Table 1. It uses the cell address value returned by the findLocation function above. The current number of markers added to the grid is compared to the number added to Table 1. Thus, the code can ascertain whether a human or Excel moved last. When Excel enters a marker, Table 1 is not updated, whereas when a human enters a marker, the code does update Table 1. So I am in effect using the Excel worksheet as a location to store global variables between script runs. This could have been done using a list in SharePoint, but the purpose of the application is to showcase the capabilities of Excel, not lists. Thank you for attending this demo. Here are the links.